Welcome everyone, this is Sikder. Today we're going to do a lesson of least square regression. We're going to examine the examples of least square regression. We're going to examine all the problems that we can examine. We're going to examine what is least square regression. Okay, what is least square regression? It is a statistical method of finding the line of best interest. It helps to find the relationship between two variables on a two-dimensional plane. The method of least squares is a standard approach in regression analysis to approximate the solution of overdetermined systems. For example, sets of equations in which there are more equations than unknowns. Least squares means that the overall solution minimizes the sum of the squares of the residuals made in the results of every single equation. When we calculate the least squares regression by hand, the first step is to find the means of the dependent and independent variables. Linear least squares, which is also LLS, is the least squares approximation of linear functions to data. It is a set of formulations for solving statistical problems involved in linear regression, including variance for ordinary, which is unweighted, weighted, and generalized correlated residuals. Numerical methods for linear least squares include inverting the matrix of the normal equations and orthogonal decomposition methods. Polynomial least squares describe the variance in the prediction of the dependent variable as a function of the independent variable and the deviations from the fitted curve. The points of the graph are called an error. It is similar to the linear equation. It is also a line of best fit. It is also the accurate way of finding the line of best fit. You have line equation of slope, which is the letter m, the y-intercept where the line crosses the y-axis, which is the letter b, how far along, which is the letter x, and how far up, which is the letter y. But not quite. Why? Why is that? Least square regression works by making the total of the square of the errors as small as possible, which is why we call this least squares. Least square problems fall into two categories: linear or ordinary least squares and nonlinear least squares, depending on whether or not the residuals are linear in all unknowns. The linear least squares problem occurs in a statistical regression analysis. It has a closed form solution. Here's an example. Sam found out how many hours of sunshine versus how many ice creams were sold at the shop from Monday to Friday. This is an example. Sam found out how many hours of sunshine versus how many ice creams were sold at the shop from Monday to Friday. Okay, we're gonna show you. Okay, right now, right here, X is the hours of sunshine, Y is the ice cream sold, That means for 2 hours of sunshine, 4 ice creams are sold. For 3 hours of sunshine, 5 ice creams are sold. For 5 hours of sunshine, 7 ice creams are sold. For 7 hours of sunshine, 10 ice creams are sold. For 9 hours of sunshine, 15 ice creams are sold. Let us find slope and y-intercept that suits that data. And here's your equation. What you have, y is equal to mx plus b. Okay, so m is the slope, b is your y-intercept, similar to a slope form equation that many of you are already familiar with. Now we move on. For each xy, calculate x squared and xy. You already have your x squared from above, and y right here, which is above. X squared is this one. You take 2 for the x. 2 squared is 4. 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 squared is 81. Now, for this one, you have to times x by y. Now you got to do 2 times 4, and that's 8. 3 times 5 is 15. 5 times 7 is 35. 7 times 10, which is 70. 9 times 15, which is 135. Now, what you got to do now is sum up x, y, x squared, xy, given that we have x, y, x squared, and xy. You already have your x and xy, x squared, and x times y listed in the bottom from above. Now you just have to sum it. The sum of x is 26. The sum of y is 41. The sum of x squared is 168. The x times y is 8. X times y is 263. And you have your number of data values, which is 5. And by the way, this is right here. You have 1, 2, 3, 4, 5. This is the number of data values, which is given there. Now you have to calculate your slope. M is equal to n times xy minus x times y times n times x squared minus x squared, which is 5 times 263 minus 26 times 41, which is times 5, times 168 minus 26 squared. And that's equal to 1,315 minus 1,066 times 840 minus 676. And that's equal to 249 times 164, and that's equaling to 1.15183. Now you got to calculate intercept B, which is y minus m times x times m. Okay, so now 41 is y. 41 minus 1.5183 times 26 times 5 is equal to 0.3049. Assemble the equation of a line, and you already know what it is. The equation of a line is y equals to mx plus b, which you're familiar with. I'm sure you're familiar with that. Y is equal to 1.518x plus 0.305. And now let's see how it works. Okay, you already have your x, which was listed previously, y previously. Now you have your y, your equation of a line, which is right here. All you have to do is plug your x's into this, and then you get your answers. Now what you have to do now is find your errors. And to find your errors, you have to use this equation of a line answer, minus it by the y. So in this case, it's 3.34 minus 4. That's equal to negative 0.66. 4.86 minus 5 is negative 0.14. 7.89 minus 7 is 0.89. Okay, so now 10.93 minus 10 is 0.93. And 13.97 minus 15 is negative 1.03. Okay, now what you're gonna look at is that you have to graph now. In your curved line that shows xy coordinates, which is 2, 4, 3, 5, 5, 7, 7, 10, 9, and 15. And that's what you get for the curved version. For the straight line version, that's the y equals to 1.518x plus 0.0305. You have to plot these ones. The y is this one, this one, this one, this one, this one. And you just have to plot it right over here. And then you get this straight line formula. And that's about it for this one.